Okay, so number one, the graph of f of x equals x squared, that's our parent function, just a regular plain old parabola, was transformed to create the graph of g of x, which is f of x minus 9. So I took f of x and I just subtracted 9 from it. So which statement is true? So I think what I'm going to do first is kind of go through these and show you the way I think about them. And then I'm going to graph it in Desmos to kind of check, because if all else fails, graph it and see what you can do, and that will work for most of these questions. They give you some sort of equation either in the problem or one of the answer choices, so you can always graph those equations and try to match things up that way. So the first thing I notice is this is outside the parentheses, so I am talking about output. And I am subtracting 9, so that's going to go down 9 units. Okay, so output, I'm thinking about the y-axis, the vertical change, and negative subtracting will send it down. Okay, so let's go through each of these, and then I think also I'm going to go ahead and write what this rule would be. Okay, so the graph is a reflection. Anytime it's a reflection, there has to be a negative sign involved across the x-axis. Okay, so if I go across the x-axis, I am changing the output. I'm going from something that looks like this to something that looks like this. So if you can imagine it on the grid, now it looks like that. Okay, so that rule would be opposite f of x. Okay, the vertex, letter B, the vertex of the graph of G is 9 units to the right. That's the x-axis, so that's going to be input. Okay, so that graph would look like, here's my parent function. I'll do it in blue so I save some space. And so then if I was going to translate it or move it, shift it, translate it, move it, slide it, all those mean the same thing, to the right, it would end up being like kind of over here. Okay, so that's my input. So that rule would look like f of x minus, now I went to the right. The right is positive, so it's C. Okay, and I know this had come up, I still can't remember, I know we talked about this, and I said, oh, it's going to come up later, because it comes up here, and then it will come up in our next section, and for the life of me, I still cannot remember where we saw this earlier this year. I just haven't thought about it. This that is always there, okay? So that's part of the rule. So we are looking for positive C. And I know that's a source of confusion, and it always is, because that, for whatever reason that I'm not going to go into now, the negative sign is in the rule. So the C isn't negative, which I know is different from what we have talked about in the past, okay? That's why graphing might be a good idea, especially if you're confused about that, which is understandable. All right, letter C, the graph of x is a reflection. Again, I'm looking for a negative sign, but this time we're going on the y-axis. That's output, which means it's going to look exactly the same, because like this one's going to go over here and this is going to go over here. And because a parabola has an axis of symmetry, if you reflect the parent function around the y-axis or about the y-axis, it's going to look exactly the same as a parent function. Okay, and so that rule would be, I'm changing all my x values, it's the input, so x, because if I'm going across the y, I'm affecting the input because it's those x values that are changing. Okay, and then letter D, the y-intercept of the graph of G is 9 units below the y-intercept of the graph of f, and that is going to be our answer. Okay, so that will look like this. Here's our parent function. Pretend it goes through the origin. Let me draw it again. There's our parent function. If I shift it 9 units down, it's going to be down here at 9, and that's what's happening, so that's why D is the correct answer. Okay, so let's go look. Let me add a Desmos, and let's graph both of those, and then you'll see what happened. Okay, Desmos, go. Desmos, start graphing. Okay, so the first thing I'm going to do is graph the parent function, because it says let me find my problem again here. It says f of x equals x squared was transformed. Later on, I don't know, maybe algebra 2, at some point in your mathematical career, you will transform other functions, like you'll have a quadratic that's already transformed, and then they'll do something to it. But for this year, it is always based on the parent function. So it makes it a little easier to see what's going on. At any rate, it makes it easier to graph. Now, you could write f of x equals x squared. Actually, you do need to do that because our next equation is based off of f of x. So type in your equation, like they say. Where's my equal sign? X squared. There we go. Okay, and then I need to add another function, f of x. So now g of x equals f of x minus 9. Now you can type in g of x equals, I guess I'll do that. That might be easier. You don't have to. You can just write f of x minus 9 and it will do it. But that's okay. Let's do it exactly as it says. Equals f of x. So, oops, I didn't put my function in there. It didn't go. Okay, so I take my f of x, the x squared, and I'm subtracting 9. And then you see what happened. Well, it didn't flip over, so it's not a reflection. And it didn't move left or right, it moved down. So then you can look and say, okay, well then obviously, there we go. Obviously it's D. Okay, and I think if you graph it, it's pretty obvious that the answer is D, and there's nothing wrong with that in my opinionation right now. We do have decimals that you can graph. Okay, and what I like about it is previously we used to have to figure out what the actual function would be, but now this allows you, and so would your Inspire calculator, allows you just to type in f of x once you define that function, so that's kind of nice. Okay, so try the next problem. It should be very similar to this one. And don't forget, graph it if you need to. There's no big deal there. Okay.